Good evening, everyone. Please, if you are present, raise your hand up. Good evening, everyone. Please, if you are present in this live, raise your hand so we know those that are present and we can start quickly. Although I'm sorry for starting late, I have to take care of kids for them to sleep. So now they are asleep, we can actually do the video without disturbance. So if you are live, please raise your hands up. Raise your hands up so that I'll know that you are there. Okay, please keep raising your hands up before we start. Keep raising your hands up before we start. So we are still expecting more people. Please keep raising your hands up before we start. uh, um like I said before, I said I'm sorry for coming late. I have to take care of kids, allow them to sleep. That is why we are starting by this time instead of 6 as proposed. So if we have disrupted your plans of sleeping, we are sorry. So please keep raising your hands up so that we can start the revision class for the revision class. So I'm starting now. Thank you. I've seen at least we have 14 persons online now. So I'm starting now. So we'll be looking at the some likely objective questions and see how we can attend to them with ease without much stretch, without much stress. So this session is a question and answer. I'll be going through your answer while I'll be correcting some of the answers. So I think we will start with the theory questions because of time, so that we don't spend much time here. Start with theory questions. So we are starting with one. Number one is, for example, they ask you, define radioactivity. Define radioactivity. I think that question is a giveaway question, and it's easy for us to respond to that. So can someone give me the definition of radioactivity? If you can hear me, can someone give me the radioactivity? So when they tell you define radioactivity, they are trying to tell you to say what radioactivity is. When a nucleus when a nucleus undergo disintegration by radiation, it causes radioactivity. So radioactivity can be natural or it can be artificial, but that should be a theory question. Sorry, I said that should be a theory question. That should be an easy question to attend to. What is radioactivity? Two, state uses of radioactivity. What do you use radioactivity for? When questions like that are asked, we don't expect you to say radioactivity is used in medicine. Maybe, for example, you say number one, radioactivity is used in medicine. Then you now say number two, radioactivity is used for x-ray. You now say number three, radioactivity is used for checking bones. you see all those uses are already one, which is used in medicine as what? To bone treatment, cancer treatment, and this. That is one. You also use it in agriculture. I use it for tracing compounds, tracing crops. I use it. While we also use it for carbon dating, that is to check the age of a rock or to check the age of an historical element. So that element could be a rock, it could be human being, it could be. So you see that the uses should be across board, not just medicine. You give one for medicine, maybe you say it's used for x-ray, then you now say number two is used for gamma ray, number three is used for you are saying the same thing. So when they ask you, when a question says state three uses of radiation, you are to talk about in different angle. That is in agriculture, in medicine, in pharmacy. I use it in pharmacy for drug production, in medicine for checking and treatment of cancerous cells and destroying treatment of cancerous cells. Then in agriculture for tracing of crops, elements, and then for carbon dating too. So now, although we have done some part of this, they say nuclear reaction that generates power is, for example, if you have polonium disintegration. If you have polonium disintegration to be 238 Pu and here is 94, it now disintegrates to give you 234 uranium 92, and they say plus x. What is x? I think that should be very easy for us to solve. So what is x? What is x? What is x, class? That one is easy. What is x? Oh, the camera is on. How do I do it now? Hey, sorry, it's like I'm not positioning this thing well. Let me do it this way. This is the best way I can position it. So what is x? X is what? Okay, someone is saying he cannot see. Please try and see it. Z2. I say if you have this kind of question, we have polonium. Polonium max number is 238 and the atomic number is 94. It disintegrates to give uranium. I know you cannot see it, that's why I'm saying it. So they now say plus x. What is the value of x? X is, you have to balance it. You know, the left, the way we balance is different. The way we balance in chemical reaction is quite different from the way we balance in nuclear reaction. So you know that it is the mass. That means x will be what? It's too near. Okay, let me take it far. X will be what? X will be, where is this thing like this now? Please, you can manage it like that. So x here will be what? 4. Here will be 4. Here will be 2. So that means if the max number is 4, why is it 4? Because 238 minus 234 will give us 4. So 4 plus this will give us 238. 92 plus 2 will give us 94. So that means this particle S is what? An alpha particle. So it is called an alpha particle. So S is equals to alpha. Now that is not where the question says. So the question is now, if the atomic mass of plutonium, are we there? Are we there? If the atomic mass, good. So now the question is, if the atomic mass of plutonium 238 and uranium 234 and the alpha particles are 238.05 and the other is 234.04 and the helium is 4.00 respectively, how much energy in kilojoules is released when 1 mole of plutonium 238 decays to, so how much energy is released? You see, that question is very easy. It's an easy question. So how much energy is released? So how do you calculate energy? We know that energy, and see somebody putting argon. Yeah. Sorry, I'm going through the comment section to see what we are saying. Can we see now? Can we see now? Why is it still like this now? Why is it like this now? Yes, I think it's better now. I think it's better now. I think it's better now. Good. So the question is, if the atomic mass of plutonium is plutonium and uranium is 238.049 and that of uranium is 234.040 and that of helium is 4.00150 respectively, how much energy in kilojoules is released when 1 mole of plutonium decays to uranium 340? So you see, that question is very easy. How much? Meaning that you should calculate for the energy. And we know that in calculating energy, we say energy is equals to mc squared. Is that not it? So, and we know that this mass is usually mass defect, which is what? Mass of products minus mass of reactant. Is that not it? So what is product here? Product is this two. What is reactant? Reactant is this one. Is that not it? And they gave us this mass to be 238.049. And this mass is 238. Is it 238 or 234? 234, 238, sorry, 238.040. This is 238.049. Why this is 238.040? Then I said we should calculate for the energy. And we know C is equals to speed of light of 3.0 times 10 raised to power what? 8 meter per seconds. And remember that your mass is in what? Your mass is in what? Atomic mass units. Is that not it? In atomic AMU. Your mass is in AMU. So what is 1 AMU? You check. 1 AMU will be equals to what? How many joules make 1 AMU? We should know that. So that's the way it is solved. So you look at the mass of the product, mass of the reactant. You subtract that of product from that of reactant, you get the mass defect. Are you see it now? When you now get the mass defect, you multiply it by the speed of light. You multiply it by the speed of light. So I'll give you time to do your calculation and I'll come back. You tell me what you have gotten. Remember that the mass of plutonium is 238.049 and the mass of uranium is 238.040. So do it and So have we solved? Have we solved it? Yes, good. One no, correct. Yes, let me go through what some persons have said in the comment section. Somebody is asking what topic is this? Are you new are you new to this? This is nuclear chemistry now. This is nuclear chemistry. Good. The next person says ine, that is ine ogene ogenegba divine. Divine 1 AMU is equals to 1.67, or you say 1.66 times 10 raised to power minus 27 Kelvin. So if you have done the mass of product minus mass of reactant, you know you get your answer in AMU. Are you seeing? That is, your mass is in AMU. Remember that the question says that you should find energy in joules. I think that's what the question says. You say we should find energy in joules. So that means when we have gotten the difference, you will not, in joules, you will not do what? Because that is in kilogram. You understand? The mass you have just converted is in what? Kilogram. So, and in joules, it has to be divided by what? 1000. It has to be divided by 1000 because they said the energy, we should calculate the energy in joules. So I was thinking that somebody will have solved it and give us the answer, but let's try. Let's try and do so solve it. Just that my calculator is not here. And if I press this phone with calculator, I think everything will just wipe out to the beginning. So if you are following, you can be pressing the calculator for us or on our behalf. Can we start with that, please? Can we start with that? Please respond. Let me see. Okay. So we can start with that creation. Okay. Creation said it's okay. So let's go. We said the mass of plutonium is 238.049. So what will be the mass of electrons? We know that plutonium has how many electrons there? 94. Atomic number is the same number with number of electrons. Is that not it? So it is 94. Now, the mass of the alpha particle was given to us because it is alpha particle that we calculated that will balance the product aspect of the reaction. And we know mass defect is mass of product minus mass of reactant. So since we have gotten the AMU, because their masses were given to us in AMU, atomic mass unit. So you need to convert the atomic mass unit to what? Kilojoules. But before you do the conversion, you must have done your mass of product minus mass of reactant. That is your change of M. So your change of M is what you convert to kilojoules. Because why do you need to convert to kilojoules? Because energy is calculated in kilojoules, not in atomic mass units. So what are the things in the product? Uranium and alpha. So what are the masses of uranium and alpha? Add them together. 238 plus 040. Sorry, 238.040 plus 4.00. The mass of uranium was given to us as 4.001506. 4.001506. So that will give us the total mass of the product. The mass of the reactant is just the plutonium that is a reactant. So it's 238.04. Subtract it. When you subtract it, you get a value. What will be that value? Please, someone should subtract it and give me the value. What will be that value? This is what I'm saying. Mass of product is 238.040. This alpha is given to us as plus 4.00 you close the bracket, minus your reactant. Your reactant is plutonium, which is 238.049. So delta M is equals to 0. What? Somebody should give us the answer. I'm waiting. Delta M is equals to what? Good. 234 for product. Okay, do the total subtraction. Let's see. What will delta M give us? Oh, SARS, bless you. Say you don't understand. This is a mass defect now. Are you just joining us? The question is we should calculate for energy. If you are just joining us, the question is calculate for energy. And energy, to calculate for energy is MC square. So, good. Yes, 3.992. Good. So that is the mass. 3.992 if you do subtraction. Now, if you do subtraction and you get 3.992 or 993, you will now convert that to kilojoules. And we said 1 AMU is equals to 1.67 times 10 raised to power minus 27. So if 1 AMU is equals to 1.67 times 10 raised to power minus 27 kilogram, therefore this value will be what? That is this value, which is 3.992 times 1.67 will give us the mass in kilojoules. Sorry, in kilogram. So if you say you have 3.992, so convert 3.992 to kilogram. 1 AMU is equals to 1.67 times 10 raised to power minus 27 kilogram. Therefore, 3.992 AMU is equals to dash. You cross multiply. That is 3.992 times 1.67 times 10 raised to power minus 27 kilogram. Are you seeing it? So when you have done that conversion, you will now multiply it by your speed of light. And we know the value of speed of light will be what? 3.0 times 10 raised to power 8. It is not 6.667. Somebody is putting clever joy. You are putting 6.66. Is that what you got after multiplying? Is that what you got after multiplying? Okay. If that is what you go, what? How did your minus 20? How did your 27 come about? Because this is minus, and I think the value of minus will still remain there. That's what I think will still remain there. But you are putting a positive minus 27. So go through your calculation again. Okay, can you see it now? I think it's clearer now. I think it's clearer. Good. 6.63 times 10 raised to power minus 27. That will be the value that you will have. Then the next is to calculate for the energy. The next is to calculate for the energy. So if you multiply that value to get in kilojoules, the answer you have gotten in kilojoules, you multiply it by square of the speed of light. Square of the speed of light is 9.0 times 10 raised to power 16. That is square of the speed of light. Your value in kilojoules, your energy in kilojoules. But the question says calculate it. Okay, they say how much energy in kilojoules, so you leave your answer like that. But when they now say convert to joules, you know you divide by 1000. So that is how that question is. The next question states state the first law of thermodynamics. I think everybody can state that. First law of thermodynamics, we can all state that energy can neither be destroyed, can only be converted from one state to another. And what will be the second law? The second law talks about what? Spontaneity of a reaction. Is that not it? So you can state second law. You can even state third law. So that is easy. So you should learn how to state thermodynamics. Then number 2, state the condition for a reaction to be spontaneous. 2 conditions for spontaneity of a chemical reaction. How do you know that a reaction is spontaneous? A reaction is spontaneous when we have a negative delta G. That is when the free energy is what? Negative. You get a spontaneous reaction. But when it's positive, you get a non-spontaneous reaction. So if delta G is negative, you know, spontaneity of a reaction is determined by the value of delta G. Is that not it? And what value is that? What is the equation? The equation is delta G is equals to delta H minus T delta S. So meaning that if delta G is negative, the reaction will be what? The reaction will be what? Spontaneous. But if it's positive, the reaction will be non-spontaneous. Is that not it? Then also, you can also use entropy to determine a spontaneity of a reactant, which is delta S. For delta S to be so for delta S to be positive, the reaction will be spontaneous. Because if delta S is positive, it means delta H will be negative. Is that not it? And if delta H is positive, delta S will be negative, and that makes a reaction to be what? Non-spontaneous. But for spontaneous reaction, delta G has to be negative. And for delta G to be negative, delta X will be what? Positive. And delta H will be what? Negative. That is how to get a spontaneous reaction. So stay tuned. The next is calculate delta H for an unknown reaction. By the time you see calculate delta H for an unknown reaction, delta G negative value, yes. For unknown reaction, for example, we are given a reaction like this. The reaction is this markers not writing. to give us 2I2 plus 2H2O. Not such. And we are giving H2 plus I2 to give us 2HI with a delta G. Let's say your delta H is equals to plus 20. And the next one, you are giving H2 plus O2. H2 plus O2 to give us 2H2O, and delta H, I mean, is minus 400. This is kilojoules. Remember that it's measured in kilojoules per mole. So, and you have to look for this delta H. If you have to look for this delta H, the question is given to you like this, and they tell you look for delta H of the first equation. What do? The first thing that comes to your mind is Hens law, because Hens law states that the sum of individual, the overall, the enthalpy of the overall reaction is equals to the sum of the individual enthalpy change that are involved in the steps of the reaction. So when you look at it, the first thing is to reason. Look at the two reactions. HI, is it appearing as the product? Compare it with the unknown. That is the first thing. Compare your two reactions with the unknown, starting from the reactant. HI is at the reactant. But if you have the known enthalpy, you see that it's appearing as the product. And the molecules of HI for the unknown is 4. But the molecules of the reaction 1 at the product is 2. So what do? It means that you have to form a reaction that looks like that first one. And what do? It means this reaction will be reversed. That is reaction 1 will be what? Reversed, so that HI can appear as the reactant and H2 plus I2 will appear as the product. Are you seeing? Then after reversing, when you reverse the delta H will also reverse from plus to minus. So after reversing, what happens? You will now multiply it by 2. All the equation, whatever you do to the equation will affect the enthalpy. So when you multiply it by 2, your HI will now be 4 molecules which align with the unknown reaction. Are you seeing it? Which align with the unknown reaction. And as such, we'll be having something like this. Reverse 1, which is 2HI will give us H2 plus I2. Now, here is 2, but here in the equation is 4, so you multiply this by 2. So it becomes 4HI will give us 2 molecules of H2 plus 2 molecules of I2, and that will affect the enthalpy. 2 times 20 will be what? 40. Whatever you do to the equation will affect the enthalpy. That is number 1 step. Number 2, you will look at oxygen again. Oxygen is at the reactant of the second reaction, so there's nothing to change there. Water is at the product, there's nothing to change there. And I2 is now at the reactant from the new equation. So you will now solve the enthalpy, adding all the reactant to reactant, product to product, then add up the enthalpy. I think that one, somebody can give us the answer to that. Are we following? So somebody can give us the answer to that. Okay. So you see, it's easy. Yes, it will be minus 40. Yes, you are correct. It will be minus 40 because it was reversed. Mm. Minus 40 because it's reversed. You are correct. Okay, the last part I said, after you have reversed, you will now add up your new equation with the second equation, reactant to reactant, product to product, and you will cancel out the like things. Just as you will do it this way, this will be the reaction 2 and this will be your new equation. Let's say equation 3. So add 2 plus 3, meaning you will put it to reactant H2 plus O2 plus 4Hi to give us 2H2 plus 2I2 plus what? 2H2O. So you cancel it out. This one is 2 here, this one is 2 here. So what is left? Does it look like the original? Yes. So since it look like the original, it means you will now add up the enthalpy. So it means you will add up the enthalpy. And in adding up the enthalpy, it becomes minus 40 minus 400. Is that not it? So that is minus 440. So you see, chemistry questions are easy. Now, the next thing is colligative properties. When we look at colligative properties, we know the properties actually depend on the number of atoms and molecules of the solutes and not the nature of the solute or solution. So, and these factors include lowering of vapor pressure. You can list the rest for me. Lowering of vapor pressure, depression of freezing point, elevation of boiling point, and osmotic pressure. So that should not be an issue. That should not also be an issue. Are you seeing it now? That should not be an issue. So we can easily do that. Now the next is if camphor met at 178, 179.8 and has a freezing point constant of 40, when 0.186 of plant, this one is something that I feel that we can easily do to calculate the molar mass. When they give you a question to calculate molar mass from freezing point, we know what to do. And what do? If you know that freezing point is change delta Tf is equals to minus Km. Is that not it? Kfm. And we know that that m is molality and not molarity, but it is called molality. And what is molality? Molality is the number of moles of solute over the mass of solvent in kilogram. In kilogram. So it is when you have seen mole, that is when you can calculate for molar mass. So it's more easy to calculate from depression than to calculate from lowering of vapor pressure. Next is Arrhenius equation. What is Arrhenius equation? We know that the Arrhenius equation helps to explain the collision between molecules, the effective collision. Please, ma, I didn't hear you. Oh, please, you have to hear. Oh, time is going. You have to hear. Okay, but you can hear me now. Can you hear me now? If you can hear me now, please let me know so that I know that let me not shout and wake the children. Can you hear me now, please? Can you hear me? Can you hear me, please? Okay, thank you. So, I said colligative properties, we have elevation of boiling point, we have depression of freezing point, and we have lowering of vapor pressure. And we know that all these are for solution and not for gases. They are for solution. So what would be an ideal gas? Sorry, an ideal solution. An ideal solution is a solution that obey RAS law, while a non-ideal do not what obey RAS law. So we know the differences, that the change in volume for an ideal gas is always equals to zero. Also with the enthalpy is always equal to zero. But for a non-ideal gas, it can be negative, it can be positive. That is why we have positive deviation and negative deviation. Are you seeing it? But the question is, how do you calculate molar mass for vapor pressure from depression of freezing point? How do you calculate molar mass from it? We calculate molar mass from it using the word molality. Using what? Molality. Because from depression of freezing point, we have it as delta Tf is equals to minus, because it's freezing point, you must put it as minus because that indicates the depression, freezing. The temperature is decreasing. Is that not it? With n. What is n? So that means if this value is given to you, this value is given to you, you will just collect like things by dividing through by kf to make a molality subject of the formula. So we know that this is a molality. So when you have gotten your molality, now what is the formula for molality? Molality means number of moles of solutes all over mass of solvent in kilogram. So remember to put your mass in solvent in kilogram. So that is how to calculate for. So when you have gotten your number of moles, the next thing is to now link your number of moles to mass to get the molar mass. Number of moles is equal to mass in gram over molar mass. So to get molar mass, you have to divide the number of moles by the mass in gram. And all those mass in gram will be given to you in your question. Will be given to you in your question. So that is how you can calculate molar mass from molality. So Arrhenius equation. The next is Arrhenius equation. What is Arrhenius equation? Arrhenius equation talks about the collision of molecules. That when molecules effectively collide, there are two conditions for reaction to occur. One, it must have attained a minimal energy, which is the activation energy. Are you seeing it? Then two, it must collide effectively for reaction to occur. So for the reaction to occur, it has to collide effectively. So that brings us to Arrhenius. So Arrhenius helps to bring the relationship between rate constant and frequency factor with activation energy. That increasing activation energy leads to increasing activation energy and increasing temperature leads to decrease in rate constant. So what is the formula? The formula is K, please, K is equals to A exponential EAR over RT. You can go through. That is the formula. Is that not it? So identifying the parameters. K is rate constant, A is collision factor, EA is activation energy, R is molar gas constant for 1 mole of a gas, and T is absolute temperature. So those are the revision. Then somebody say please come again with enthalpy change. Hence law now, normal Hence law. you calculate each step, check the reaction you need to reverse. After reversing, add up reactant to reactant, product to product. If it looks like the original, then you will add the enthalpy of the reactions that you know. Add the two enthalpy together that you use in adding to get the unknown reaction. That is enthalpy. It's not TF, it's delta TF. Uh-huh. Delta TF is equal to minus KFM. Yes, that is it. So I now said that how do you calculate molar mass from depression? You calculate molar mass from depression of freezing point using the molality. That's what I'm saying. So molality is equal to number of moles of solute all over mass of solvent in kilogram. So when you have gotten the number of moles of solute, it means you will now say the number of moles of that solute is equal to mass of the solute over what? Molar mass. Are you seeing it? So that is how to calculate, that is how to get molar mass from molality. So from there you can now divide through and make molar mass subject of the formula. So we have conjugate acid, we also have conjugate base. What is a conjugate acid? What is a conjugate base? We should know that. We should know what a conjugate acid is, what a conjugate base also is. Yes, it has Van off factor. I. Thank you for putting that. But it's not, it really do not affect because we know that Van off is always one. Is that not it? It's always one. But you can put it I. I is Van off. Van off is always one. Always one. Hmm? For a non-volatile solute. You understand? It's always one. So sometimes they won't give you the Van off, but you should know that Van off is always what? One. Thank you. Thank you for that. The colligated, what was I saying? Conjugate acid and conjugate base. What is a conjugate acid? What is a conjugate base? Do you know how to identify them? Are you saying, do you know how to identify them? So first of all, what is a conjugate acid? When a base loses its proton, it becomes a conjugate acid. And when an acid gains a proton, it becomes a conjugate base. Are you seeing it? So that is the definition. Now, how do you identify them? How do you identify them? We have virtually touched on all areas of chemistry that we have done from the video. So how do you identify them? Sorry, I'm feeling sleepy now. If you have H3PO4 plus NH4, sorry, NH3, so this is 2 minus to give us HPO4, 2 minus plus NH4 plus.
Yeah.
Excuse me. So look at the equation, which is conjugate acid, which is conjugate base. Which of them is conjugate acid? Which of them is conjugate base? Which of them? I'm waiting for you to answer. I told you that this session is you answering question and me helping you to know whether the question you answered is right. So identify the conjugate acid and the base in that reaction given to you on the board. So what is the conjugate acid, class? So what is conjugate acid? What is conjugate base? I say a conjugate base is formed when an acid loses a proton, and a conjugate acid is formed when a base gains a proton. When an acid loses a proton, it's a conjugate base. When a base gains a proton, it's a conjugate acid. So within the two equations, you will look at it. Which of them has gained a proton? From ammonia to ammonium, you see that he has gained a proton. So since he has gained a proton, what will he be? A conjugate acid. Then from H2PO4 minus to HPO42 minus, you see that he has lost a proton. And when he loses a proton, it becomes a conjugate base. So that is conjugate base, while the ammonium ion is a conjugate acid. At least clap for me now. Clap for me because none of you answered it. So that is it. I'm not seeing the clap, oh, but I should stop the class. Nice one. Good. So the next is how to calculate order of reaction. Hmm. How to calculate order of reaction. Thank you. Thank you for the clap. So if you are given this kind of question to calculate the order of reaction and the rate constant, what do you do? Please take the question down and let's do the calculation together. Um, So the question now is to calculate. You are given this set of value. They now say calculate the order of reaction and the rate constant. Calculate the order of reaction and the rate constant. It's very easy. What do you do? Remember that to calculate order of reaction in a complex experiment, you will use rate 1 over rate 2 equals to conc 1 over conc 2. Or rate 2 over rate 1 equals to conc 1 over rate 2 over conc 2 raised to power what? N. That N indicates the order of the reaction. The N indicates the order of the reaction. Is that not it? So I think this one is also easy for everyone. If you are used to calculating order of reaction, other complex reactions. We talked about molecularity and order of reaction. And we said the formula to calculate order of reaction for a complex reaction is always rate 2 over rate 1 equals to conc 2 over conc 1 raised to power what? N. For a complex reaction, you say rate 2 over rate 1 equals to conc 2 over conc 1 raised to power N. So put that into the equation. So how do you do it? What will be your rate 2? For each experiment, we have how many experiments on the board? We have 3 experiments. So if you are taking 1 and 2, you can take 1 and 2 and you can take 2 and 3. Do you understand? Meaning that if you are saying rate 2, that means rate 2, which is 0.040, divided by rate, sorry, I say rate 2 is, sorry, concentration. Concentration is 0.020, and the rate for that concentration is 4.4 times 10 raised to power minus 6. The concentration is 0 for the rate is 5.0 times 10 raised to power. So when they now say rate 2 over rate 1, it means you say experiment 2, this experiment 2, that is that experiment 2 over experiment 1. Are you seeing it? Experiment 2 over experiment 1. So it becomes rate 2. What is the rate of experiment 2? Is 5. 5 times 10 raised to power minus 6 all over 4.44 times minus 6 equal to what is the concentration? 0.04 divided by 0.02 raised to power n. Remember that when you have done that, you will now look at the base. You make sure that the base are equal. Are you seeing it? You make sure that the base are equal. If you cannot make sure that the base are equal, there's another way to do it. Are you seeing? There's another way to do it. What is that way? Remember that the law of indices says that anything raised to power will come down. Log to the answer. That is it. That is indices. Are you seeing it? So you put them in the same base or take a log to calculate for n. So use your textbook there. So you can use it to calculate and tell me what you have as your answer. Before we sleep, we are about to end the class. Lastly, before we sleep, when Q is greater than K, remember what is Q. What is the difference between equilibrium constant of concentration and quotient? The difference is that equilibrium constant of concentration occurs at equilibrium, but quotient occurs at any time of the reaction. They have the same formula, but one does not occur at equilibrium, which is the quotient. Quotient does not occur at equilibrium, but equilibrium constant of concentration occurs at equilibrium. Excuse me, please. Sase, wake up and go to your room. Go and wee wee before you go to your room. So you don't wee wee on your bed. Good night. Bag the door for me. Okay, good night. Make sure you will. Sorry for that break, eh? No children. You must surely ask. So I think we've virtually spoken about everything. We have virtually spoken about everything. Okay, what do I mean? I mean, you have rate 2 all over rate 1 equals to conc 2 over conc 1 raised to power n. What do I mean? If you divide rate 2 and rate 4, assuming it gives you 4, and here gives you 2 raised to power n, you will make 4 and 2 be of the same base. And how do you do that? It becomes 2 raised to power 2 equals to 2 raised to power 2 equals to 2 raised to power n. So n will be equals to 2 because these two are of the same base. Otherwise, you can decide to say by law of indices, anything raised to power, if you have log a b raised to power c, it becomes c log a b. Are you seeing it? So that means you are introducing log to both sides. You first of all introduce log to both sides. When you introduce log to both sides, you will now apply your law of indices that says anything that goes up will come down. So from there you can calculate for. From there you can calculate for n, and n indicate the number of the order of the reaction. So when you have gotten the order of reaction, how do you now calculate the rate constant? It means you will express it. You will express rate. How do you express rate? Rate is always expressed as rate equals to k raised to power the coefficient. That means, for example, you have 2. You know that the order of reaction is 2. So how do you express it? It becomes rate is equals to k concentration, whatever chemical they ask you to find the concentration, then raised to power 2. So that is how to express rate of expression, rate law. Remember how to express rate law, where we say rate is equals to k concentration of the compound raised to power 2. So you pick any of the concentration. If you are picking experiment 1, you use the rate 1. If you are picking experiment 2, you use rate 2. Are you seeing? And the concentration of what? 2. That will that will guide you on how to calculate for rate constant. So you make rate constant the subject of the formula by dividing by the concentration of the compound. Hmm? Mhm. You are welcome. So that is it. Now remember that we have a Kp and Kc. What is Kp? Kp is the equilibrium constant of pressure, and Kc is the equilibrium constant of concentration. What is the relationship? When you are asked such question, you remember that we said that the relationship of Kp and Kc is guided by PV equals to nRT. Is that not it? So from there, we were able to derive that Kp is equals to Kc RT delta RT raised to power delta n. Please go to Go to your note on that relationship between those two, KP and KC, and know it and identify the terms. Try to know them and identify the terms. So how do you calculate for KC or calculate for KP? In calculating for KC, we know that KC is equals to concentration of the product raised to power its coefficient all over concentration of the reactant raised to power its coefficient. So if you have gotten, excuse me, if you have gotten the concentration, how do you calculate for concentration? Concentration is number of moles over the volume in liter. Is that not it? For a this person that is saying that please molecularity and order are almost the same. Yes, they are almost the same, but it's only for a simple reaction that they are the same. Only for a simple reaction, you use the coefficient to determine the molecularity, and you also use the coefficient to determine the order. But when it comes to complex reaction, they are not the same. We have the difference between, in short, you just go and read difference between order of reaction and molecularity. I think we have up to 3 to 4 differences there. 3 to 4 differences. At least we should know those differences between order and molecularity. Are you saying? We should know those because order is experimentally determined, but molecularity is not experimentally determined. It is the whole number that is used. It's stoichiometry that is used. So going back to where we were, Kp is equals to Kc ROT raised to power change in N. And we know that change in N is equals to what? N of product minus N of reactants. N of product minus N of reactant. Okay, somebody said he got one with the values I gave, he got 1.13 raised to power 2N. Hmm. Hmm. How do you now get the N? You try to make that 1.13 to be of the same base with 2. So if you cannot think of decimal place like I said, you use the other one by introducing logarithm to both sides. Just use the other one by introducing logarithm to both sides. But most of the time, the values are always where you can easily get the same base. Are you seeing where you can easily get the same base? Or the best thing, another thing you can also do, may not be the best, but another thing that you can also do is to introduce logarithm to both sides and apply the rules of the laws of indices. When you introduce log, you will now get n will come down, you will now divide through by the log of concentration 2 over concentration 1. So you can do it that way also. Somebody is asking, ma, please do revision for tomorrow exam. What am I doing? I'm speaking to myself, Abi. Am I speaking to myself? So I will not just sleep today because that is what we are doing. It seems it's like you are just joining us, so that is what we are doing. So if you have been following up, you follow up with you watch the program again. Otherwise, this is what we are doing. This is what we are doing. So we are doing revision. We are doing areas of concentration. So I was saying something about KP and KC. And I think we know how to solve for KP and KC. So if you have gotten a KC for a reaction and they gave you the equilibrium, the quotient, that is equilibrium constant of concentration that occur at any point in time of the reaction, they gave you a value for it. And maybe after you have calculated, you saw that your KC value is less than your Q value, because I told you the difference between Kc and quotient. I said quotient is equilibrium constant that occurs at any point of the reaction. But Kc is equilibrium constant that occurs at equilibrium. That is the difference. One is occurring at equilibrium while the other is occurring at any point in time. So now, what do you do? They gave you they gave you quotient and they gave you Kc. They now tell you compare the values. If Kc is greater than uh, if Kc is greater than Q, where will the equilibrium shift to? Make comment on the equilibrium shift. That is what they will tell you. Make comment on the equilibrium shift if Kc is greater than quotient Q, or Q is less than quotient. Please go and learn that one. Know the difference. But one thing is sure, that when Q yeah, I'm getting tired. I think after this one, I will go and sleep, my dear. I've tried my best. Which one is KSP? KSP is a product solubility product. Yes, you will study that one too. You study solubility products also. But if Q is less than K, it means the product is too small, the reactant is too large, and therefore the equilibrium will shift to the forward reaction from left to right, and the reaction will proceed from left to right, and the equilibrium will shift to the right to favor the forward reaction. So when you have calculated for Kc, you will compare it with the value given to you as Q, if it is greater or if it's lesser. If Q is less than K, it means the equilibrium will shift to the right to favor the forward reaction. But if Q is greater than K, it means equilibrium will shift to the left to favor the reverse reaction. But when Q is equals to K, it means it's at what? Equilibrium, and is the system is at equilibrium. That's what it means. The system is at equilibrium. Exactly. So that is it. Next is I think that is all. Yes, lastly, what is the difference between voltaic cell and electrolytic cell? We should know the difference between voltaic. Now, I'm saying this electrolysis because of somebody that called me to ask me about this question. Are you seeing it? Somebody called me to ask me about this question. I was like, why did the person ask me this question now? Please, it is important you know that we have electrolysis, and electrolysis operates in an electrochemical cell. And what is an electrochemical cell? Electrochemical cell is the compartment where electrolysis can occur, that contains electrode, both positive and negative electrode. It contains electrolytes. Are you seeing it? It contains electrolyte. It may have salt bridge or not, depending on the kind of electrochemical cell. So that means we have two types of electrochemical cell. What are these two types of electrochemical cell? We have the voltaic cell and the electrolytic cell. Those are the two types of electrochemical cells. So don't use electrochemical cell to confuse yourself. Two cells are under electrochemical cells. And what are they? Voltaic and electrolytic cell. So what is the difference? Voltaic cell is chemical energy to electrical. And electrolytic cell is electrical energy to chemical energy. That is how the conversion is. Now, the electrodes of voltaic cell, remember the diagram that we drew, that the arrow point from the anode to the cathode, and we said the anode is negative. But for an electrolytic cell, negative, the anode is positive and what am I saying? No. Yes, the anode is positive and the cathode is negative. And we now said that oxidation always occur at the anode and reduction always occur at the cathode. At the cathode. So I think that's all I can take. I'm already getting tired. Sorry, I want to sleep. Um, if you enjoy the class, let me know by your clap. Give me a clap offering now so that I know that we are together in this. Nobody is clapping for me. Yeah. Thank you. I appreciate all of you. Please go and pass, go and dust chemistry. Please, oh, no account should anybody carry expo to the hall. Expo is not allowed. Don't use your phone. All those are exam malpractice. Please, I know you can do it. With all this video, I know that you can do it. And just keep reading, and God will help you to achieve your goal. God will surely help you to achieve your goal. The only way God can help you to achieve your goal if you are not involved in exam malpractice. Because once you are involved in exam malpractice, it's useless. It's useless. So please ensure that you don't involve yourself in exam malpractice. Keep believing in yourself. Keep knowing that you are a good child. You are intelligent. You are smart. And remember that if you are in my wing, somebody said that we do expoma. Don't do it. Oh, don't do expo. Who is that person? Let me see the person's name sef. Chinso, I will look for you. I'll use camera to look for you. Don't do it. Don't do expo. It's wrong. It's bad. It's bad. It does not make you a child of God. So why I'm saying this is that I know that you are smart. If you are in my class, you remember I always tell you to speak to yourself every morning. Speak to yourself every morning that you are smart, you are intelligent, you have retentive memory, you are beautiful, you are what God says you are, and please go and do exploits. Go and do exploits. So thank you and God bless you. See you tomorrow. See you tomorrow. How do I?